Physics 1, fall 22 exam. Throw a baseball up into the air with a speed of 80 meters per second. So if I draw this, it's going to go up, and it's going to come back down again. I want to know what is the total time in the air. This initial velocity is equal to 80 meters per second. So for the first part, I want to find what is the time to get to the top. And I know that v at the top of this trajectory is equal to 0. So I'm going to say that v at the top is equal to v naught plus a times t. So that's 0 equals 80. A is minus 10 times t, so I get t equals 8 seconds. Then the total time, which is what I'm looking for, is twice this t at the top. I'm going to call t top. Twice t top. That's going to be equal to 16 seconds. So that's the answer to that one. I also want to know what is the maximum height. So what is the position up here? So since I already have the time at that location, I can just use this parametric equation, this y equal v naught t plus 1/2 at squared. When I say parametric, I just mean that y as a function of time, that's what parametric means, that it's an equation as a function of time. I'm looking for y. I know all these other values. That's going to be 80 times 8. Excuse me, I'm looking for the position. I know all these other values. Plus 1/2. My acceleration is minus 10. 8 squared. If I do that, I get that the answer is equal to 320 meters. And then finally, for part C, I want to know what is the velocity at 12 seconds. Well, I give you the time, t equals 12 seconds. So I just say v is equal to v naught plus a times t. That's equal to 80 minus 10 times 12. And that's going to be 80 minus 40 meters per second. So it's 40 meters per second. It's in the downward direction. And then finally, I want to know the graph of the velocity versus time graph. That ball starts out with a big positive velocity. It decreases until it goes to 0, and then it increases in the negative direction. So it should look like that. Okay, a truck increases its speed from 30. V naught equals 30. V final equals 40 meters per second over a distance of x equals 100 meters. And I want to know what time does this take, and then also what is the acceleration. Well, there are two kinematics equations, and both of these have two unknowns in them. The first is that v is equal to v naught plus at. I'm going to put these values in. So 40 equals 30 plus a times t. And then the second one is that x is equal to v naught t plus 1/2 at squared. That is 100 equals 30 times t plus 1/2 of at squared. So what I'm going to do is this is a system of two equations. So I have to solve one of the equations and plug it into the second one. There are a couple different ways that you can do this, but the easiest way is to solve this for a. So I'm going to have at equals 10. I subtracted 30 from both sides, and then I solve that for a. So I get a is equal to 10 divided by t. Then I can take that and plug it in for a right here, and you'll see what happens. Makes this a lot easier to solve. 1/2 of 10 divided by t times t squared. Notice that this t cancels out with that t, and I'm left with 100 equals 35t, which I can solve for t fairly easily. Divide both sides by 35, and I get t equals 2.9 seconds. Now that I know that time, I can take it and put it in here, and I get the acceleration of 3.4 meters per second squared. So those are the correct answers for both of those. And here I have this graph. I want to know the instantaneous velocity at t equals 15 seconds. That's at this point right here. So I want to find the slope of the tangent line, which is there. My rise, it goes from 0 to 10, so my rise is 10. Notice it is a positive 10. And my run goes from 10 to 20, so that also is 10. So my instantaneous velocity for part A is the slope of that line, which is going to be 10 meters over the that's the rise over the run, which is 10 seconds. That's going to be 1 meter per second. and that is positive. And then I want to know what is the average velocity between t equal 5 and t equal 25. So t equal 5 is right here, and t equal 25 is right here. So I can do this in a similar way where I'm finding the slope of this line, or you can do the x final minus x initial, where this is x final, this is x initial, but that gives me a rise of 5, and then my run goes from 5 to 25, so my run is 20. Rise over run, that gives me 5 over 20 meters over seconds. That is 1/4 or 0.25 meters per second. Those are the answers there and there. Now let's get to the multiple choice of this test. What is the volume of a medium-sized apple? Well, you know, a cubic centimeter is about that. Uh, is that the right size? It depends how big your screen is, I guess. But anyway, you look at your pinky. The end of your pinky is about a cubic centimeter. And so how many of those will fit into an apple? It's definitely not A or B. C would be a pretty tiny little apple. So it's actually going to be D, that a normal sized apple is about 100 cubic centimeters. What's the width of your head? Well, unless you're like a really big head, my kids, well, never mind. Never, doesn't matter. What's the width of your head? It's going to be, no, about 10 centimeters. And 10 centimeters is about 1 meter, zero point 0.1 meters. That's for sort of a, yeah, that's sort of a normalish head. But it's definitely not 10 meters or 1 meter or a hundredth of a meter. That would just be 1 centimeter. So zero point 0.1 meters is really the only one that makes any sense. Let's look at these dimensional analysis problems. I'm going to put in the units for each of these. So that's going to be V is meters per second, 1 over seconds. That gives me meters per second squared equals meters per second squared. Okay, so far so good. Leave off the half. That's meters per second, but it's squared, so they're both squared, and then 1 over meters. That meters cancels with one of those, and notice I have meters per second squared on all those, so that one's okay. But this is just our kinematics equation, so I'm not going to go through it, but you can put in the units there, but it is one of our kinematics equations, so I know its units are correct. And here I have meters per second, meters per second squared, seconds. Okay, so far so good. Plus meters. Oh, and then I have 1 over meters per second, which is seconds over meters. Meters. But that cancels out. So while these two are okay, that one's not. So that one is not dimensionally correct. So D is the right answer. What are the units of this equation? All right, meters per second squared. Meters, seconds over meters. That's my 1 over V. And then 1 over seconds. That cancels, 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 cancels. And I'm left with this. Which of these is the correct answer for this expression? Okay, well, first of all, I do this, always do multiplication and division, or always do parentheses first and then multiplication and division. So that would be 12.1, but I would just represent it as 12 plus 3.4. Okay, sorry about this. I actually changed this, so this is going to be 3.6. So let's make this into 3.6. That's what your test will read. Um, so 12 plus 3.6. If I add it up, I get 15.6, but I keep proper sig figs. It's just going to be 16. I keep the lowest number of decimal places. Remember, for this, keep the lowest number of sig figs. And then for addition, keep the lowest number of decimal places. So 16 is the right answer. This is the standard for the kilogram. The standard was changed because the artifact had a changing mass. There were some other reasons, like it was not uh, accessible, but that's not one of the options. It's definitely not because the U.S. government had anything to do with it. Oh, the U.S. government did have something to do with it, but that's not why. It's not that the physical constant had become irrelevant. In fact, it wasn't based on the physical constant, and it wasn't that they discovered a new physical constant. The physical constant was actually quite old, that we long known for a long time, and of course it's not E either. All right, what is the length R here? Well, recognize I got a triangle. It is a 3, 4, 5 triangle. Notice square root of 3 squared plus 4 squared that's equal to 5. And then I also want to know the angle, so do the inverse tan of 4 divided by 3, and that's equal to 53 degrees. Um, so here, probably easier to change the inches into millimeters first. So I would have 1.6 inches, 12 inches, 1 foot. Um, in 1 meter, there are 3.28 feet. And in 1 meter, there are 1,000 millimeters. Let's just make sure I did that right. There's my inches, cancel, 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 cancel. And I'm left with millimeters. If I do all that, I get 40.65, 40.65, 41 millimeters. And then if I do the volume of that, that's going to be 4/3 times pi times 41 squared. Let's make sure I did my sig figs right there. So 4 divided by 3 times pi times 41, not squared, but cubed, excuse me. I get 29,000 or 288,000. Or yeah, so I'm gonna have to change this, but this should say 290,000. So that's the right answer, and this should be a cube right here. All right, let's go on to number 11. Car accelerates 3 meters per second squared. I don't know this in miles per hour squared. I have in 1609 meters, that's 1 mile, so that converts my meters to miles. And then there are 3,600 seconds in 1 hour. I have to square this though, so that my second squared cancels out and leaves me miles per hour squared. And if I do that, I get 24,000 miles per hour squared. Truck is at rest. V naught equals 0, speeds up to 60 meters per second, and t equal 10 seconds. And I want to know what distance does it cover in that time. Well, first of all, I need to figure out the acceleration. So I'll say 60 equals 0 plus a times t, which is 10. And so a is equal to 6 seconds. It means it takes 6 seconds to cover that time. And now I want to know the distance. That's going to be v naught, which is 0. It's just going to be 1/2 at squared, which is 1/2 of, I'm sorry, that's not 6 seconds. That's 6 meters per second squared times 6. That's the acceleration times 10 squared. That's 3 times 100, or 300 meters. Car traveling at a speed of 30 meters per second, v naught is equal to 30 meters per second, begins to slow down at a rate of 10 meters per second squared. So this is going to be minus 10 meters per second squared because it's slowing down, and this is positive. And I want to know how long does it take to come to a stop. So v final is 0. So I just say v equals v naught plus a times t. First, I need to find the time that it takes. That's going to be 0 equals 30 minus 10 times t. So t is equal to 3 seconds. And then to find x, I say that it's equal to v naught t plus 1/2 at squared. That's going to be 30 times 3 plus 1/2 of negative 10 times 3 squared, and that works out to be 45 meters. Notice here that up in this point, I didn't have that V naught T term. That was because up here in this problem, V naught was equal to 0. See, I have that right there. So that's why I left off that term. Throw an object in the air. You throw an object into the air with an initial speed of 10 meters per second. Which of these is true? It takes 1 second for the object to go up and come back down to your hand. Okay, no. In fact, it takes 1 second to go up and then another second to come back down again. So it takes a total time of 2 seconds. Um, The object speed at the top of the directory is 10 meters per second. No, it's 0 meters per second. The acceleration is not 0. The acceleration is equal to minus 10, and the time to go up is equal to the time. So that's not true either, so none are correct. If I throw a rock up in the air, which of these represent the motion of the air? Actually, these should be y position graphs. I'll fix that. Okay, so it starts out with a big positive velocity. That means a big positive slope. At the top, it has a velocity equal to 0. That means a 0 slope. And then as it comes down, it gets a big negative velocity. So A is the right answer. Consider this velocity versus time graph, which is the position versus time graph. Well, here I have a 0 velocity, so I should have 0 slope in the beginning, either here or here. So I get rid of these two because those both have big velocities initially. And then it speeds up, but it speeds up in the negative direction. Here it speeds up, but with a positive velocity. So that's not right. So the answer then is going to be C. So this position versus time graph, which of these statements is true? Is it stationary at point B and D? It is. Notice the slope of the tangent line there is 0. Has a positive acceleration as it moves from A to B. So here it has a negative velocity and it's slowing as it moves from point A to point B. That means it has a positive acceleration. So yes, that is true. The speed from point C and E is the same. There's the speed at point C, the speed at point E. Notice the slope of those two lines is equal. The signs are opposite, but the slopes are equal in magnitude, so that is true. And the acceleration at D is 0. I'm probably going to take that off. In fact, yeah, I will take that off. Uh, but the answer is no, it's not. So the answer is A. This would be just like what I have over here. And remember the acceleration here was minus 10 meters per second squared. I think I might keep it. I'll think about it, okay? So there's velocity versus time graph. What distance has it traveled? Remember, if I have a V versus T graph, I find the area to find the distance. So here I have three parts here. I have the area here is 1/2 of 2 times 4. That's 1/2 of 8, or 4. The area of this one is going to be 8, and the area of this one is going to be 2. So I add those up. What acceleration do I have at 1.5 seconds? That's right here. So I want to know this slope right here. That slope has a rise of 4 and a run of 2. 4 over 2 is 2 meters per second squared. And consider this position versus time graph. What is the object's velocity at 4.5 seconds? All right, so I'm going to draw the best tangent line that I can, or something like that. Yours might look a little bit different, but you're going to get an answer that's close. The rise for that is minus 50. The run is 1. Actually, it's minus 45, but the answer, though, the only one close to that is minus 50. All right?